So welcome to, I guess this is probably your last session for the day. Let me start with introducing myself. My name is Percy Wadia. I'm Director of Product Management in the NSPU, the Networking and Security Business Unit. With me is?
Hey guys, I'm Tipnis. I'm a Technical Product Manager working with Percy on this particular project within VMware.
Perfect. Let's start with a quick question. How many of you guys saw the announcement we made today morning regarding VMware Cloud Services? Yes. Awesome. Everybody, all of you did. So what we are here to talk about today is using VMware NSX Cloud for enhanced networking and security for AWS native workloads. The service that we are launched today is called NSX Cloud. That was part of this VMware Cloud Services announcement. So the big thing I want you to take away today is it's announced, it's live, and for the introductory period, can you hear me? Yeah, it's announced, it's live, and for the introductory period, it's actually free. So if you guys want to test it out, just want to play with it, just go to the website, cloud.vmware.com, go down to the service, it's available. You guys can just request access ASAP. Now, let me start with a disclaimer. Of course, we're going to show you a service. We have a very exciting session for you today. We're going to go through a couple of challenges that we see in the cloud. We are actually going to do almost 4 demos. So hopefully that'll keep you entertained as well. It'll give you information about what the service is all about. But things may change, right? So I want to lead with this disclaimer side. The service is under evolution. It's out today, but we have a very clear roadmap of where we want to take it. So of course, things will evolve from what you're seeing today. So this is our agenda. We're going to introduce what VMware Cloud Services is. We're going to talk about NSX Cloud. We're going to go deep into NSX Cloud, what exactly it does, how it does it. We'll do all of that. Key customer challenges. What does it mean by NSX as a service, right? What does that mean, right? What is NSX Cloud when we talk about it as a service? And then we'll talk about next steps. So first is NSX Cloud. Now, when you look at this slide, lots of things going on out here. But the big takeaway I want you to sort of take here is NSX Cloud is sort of run, manage, connect, secure any application on any cloud. Now, what that means is, if you think about it from an infrastructure stack standpoint, you pretty much have 2 sets of clouds. You have clouds, at least from a VMware standpoint, you have clouds that run the vSphere stack, and then you have clouds that are not running the vSphere stack. So that's how you sort of divide this entire map here. Now, with this, you have cloud providers. We've talked about Amazon Web Services. We've partnered with them. We have VMware Cloud on AWS. We, of course, have our own cloud foundation that you run. Here we also have the IBM Cloud for VMware. All of these clouds are essentially inherently using the vSphere stack. Now, using the vSphere stack, of course, gives us a lot of benefits that are specific to vSphere stack. We actually own the whole infrastructure. We can have a lot of sort of engagement and a lot of hooks into how that platform behaves. There is a whole new world out here, which is the public cloud IaaS, which is AWS, Azure, you have Google Compute Platform. These are all clouds that are not running the vSphere stack. Now, the question is, okay, if you're not running the vSphere stack, what else can we sort of do here? So VMware Cloud Services, if you think about it as an umbrella, gives you services on the management side, on the operations automation piece, security, governance, on both of these cloud platforms. So you have the vSphere platform, you have the public cloud platform. NSX Cloud runs on the public cloud platform. NSX, of course, runs on vSphere. Lots of you, I'm hoping, are already NSX on-prem customers. This is NSX Cloud, which runs in AWS. So what are the services that we actually talked about today? So the first one, let me start with the very beginning, is discovery. If you're running applications, applications in public clouds, first thing you really want to know is get some visibility into what those apps are. How are they behaving? What resources are they consuming? That is our discovery service. Logical transformation from that point onwards. If I now know what I'm running and what I'm consuming, what is the cost parameters here? So that's where Cost Insight comes in. Accounting, cost optimization, as you are thinking about multiple clouds, not just your on-prem, but on-prem, AWS, Azure, etc. The next piece here is basically I'll switch to Network Insight, which is I now know what's running in public clouds. I have a model on the cost. I get some insight into that. What are the network flows that are happening in this? So for example, I don't know what sort of traffic is flowing in and out of my instances in AWS. So this is where Network Insight comes in. Once I now know what's happening in the network on the public cloud, that is where NSX Cloud come in. We want to basically give you a single solution where you can manage your network and your security when you are running it in public clouds. And then we also have another service that we announced. We announced it today also, which is App Defense, which is basically governance instead of running workloads. So how do I actually get higher levels of security in those applications? So this is the gamut of VMware Cloud Services. For the rest of this conversation, we'll focus exclusively on NSX Cloud. So let's first start with what is NSX Cloud trying to do? So with that, let's first think about what do people do? I mean, who are the people who go to the cloud? You clearly have your cloud network admin. He's the guy who's basically now interested in figuring out how do I actually manage my cloud network in addition to my enterprise network. Clearly, there are two different networks today. I need to manage both of them together. How do I actually think about having one single network across all of these different footprints? Second is the visibility piece. How do I know what's happening in the public cloud? I'm in charge of making sure the network sort of is ubiquitous, it stretches across environments, but I need to know what's happening in those public clouds before I can even think about sort of making sure that it's consistent, it's ubiquitous, etc. That's his problem. This is the network admin, right? The other guy here is a security admin. He has a similar sort of challenge. He is responsible for security across private and public. Sometimes the teams are sort of either the same team looking at both, or sometimes there are teams that are exclusively private, exclusively public. But the key parameter is still the same. You don't want to sit and define two complete new paradigms for security, one that's applicable on-prem and a completely different one that's applicable in the cloud. And when I say in the cloud, I mean any cloud, right? Tomorrow I'm on AWS, day after tomorrow I might be in Azure. Should I redefine what my security parameters looks like there? Second piece, if you go to AWS today, when you're deploying the VMs, you actually specify what security groups those VMs belong to. That is the static membership of VMs coming into security group, which essentially means that every time a VM is deployed, you have to either tell the DevOps guy to make sure he puts the right security group membership, or you give him blanket security group memberships that he just calls those APIs and says, every time you deploy a VM, just create these security groups. The problem here is DevOps is going to do that, and either you are sitting with him or you don't know whether he's done the right thing. How do you make sure that the DevOps is compliant with your enterprise security policy? Now think about it from not one VPC, but 2 VPCs, 5 VPCs, 50 VPCs. You clearly see that this problem is getting more and more sort of strenuous. And last is, every time I go to a cloud, today it's AWS, tomorrow my CFO might say, look, we have a big ELA with Azure, I want to actually move everything to Azure. Do you redefine your entire security parameters? Or can I just have one operational tool set that I have on the enterprise, and I leverage it to AWS today and then maybe Azure tomorrow? That's all his problem. Let's get the third guy in the mix, the developer. His main task is, great, I want to go to the cloud, I want the agility of the cloud, I'm responsible for writing really good applications that are resilient in the cloud. I am not on point to make sure that this application is essentially secure, etc. I will do what the security policy mandates, but my focus is on application deployment and application development. How do I basically make sure that we satisfy all these, call them roles or call them sort of key players in the public cloud? This is where NSX Cloud comes in. What we are trying to say is it's consistent networking, consistent security for applications running natively in the public cloud. So the intention here is I give you visibility into your network environments. I give you security, which is one pane of glass security across your multiple clouds. I give you networking, which of course, think about it like a bring your own network aspect. So you define your logical networks. They can be applied on-prem just as well as they can be applied in AWS or in Azure. And the last is consistency. Because I'm doing it once, I'm doing it consistently across all my cloud platforms. I am not defining my rule sets, my security, my networks, depending on the footprint I'm running in. And yes, you see here, today we are talking about AWS VPCs. I don't know if you guys attended the Spotlight session that just completed. We actually demoed this same solution on Azure. there. So we actually demoed the solution on Azure. We have plans to go towards Google Cloud Platform as well. Again, the intention is multiple cloud footprints, single solution across all of these clouds. What are we getting? Just to repeat, visibility across clouds, unified security policy, network portability. You're not mandated to sit and write one set of subnets in AWS and another set of subnets in Azure, and then consistent operations. So let's dive into these problems. I already sort of talked a little bit about what these problems are. Let's go a little deeper in this. And what was I sort of talking about when I said visibility? This is my VPC. Here is my account. Of course, I have really fancy diagrams about here is my web VM, my app VM, my database VM. Each one might be on different subnets, and then I have multiple of these applications. Big question here is, how do I know all the VMs that are coming up every day in this VPC? They are being spun up by the DevOps teams. There might be multiple DevOps teams operating in this VPC. VMs are being spun up, VMs are being torn down. If you think about the whole paradigm of cloud, we talk about agility. Don't sit and patch environments in the cloud, just nuke them and get new environments in place, right? Automate your cloud deployments. But if this is happening truly at that scale, how do I get a consistent view of what's truly actually available in the cloud? This is one VPC. Now let's complicate matters. Same account, multiple VPCs. Now why would you have multiple VPCs? Well, when we've talked to a lot of customers, they say, look, VPC is my organizational boundary as well. My finance team operates in VPC A, my marketing team operates in VPC B, my operations team operates in VPC C, and they create, these DevOps teams are sort of managing this environment. You are the cloud guy, you need to make sure all of this is secure. This is across multiple VPCs. How many VPCs do you think a typical enterprise company would have in AWS? Anybody ventures a guess? Single digits, double digits, triple digits? We've had customers talk to us about 400 plus VPCs. I'll pause here for a second. 400 plus VPCs that you have to sort of see to make sure that, look, there is every single VPC has the right security groups and security policies. Now, of course, that might be an outlier. An average we can say is about 20, but still 20 to 50 is still a large number of VPCs to manage. Some of the other companies have pivoted a different side. They say, look, we're not going to have 400 VPCs. We're just going to have different accounts. So my finance team has one account, marketing team has another account. You get the picture, right? So now, and then within them, they'll say, look, we have these accounts. Let's make VPC A our test and dev VPC. VPC B, my staging VPC. VPC 3, my production VPC. 3 accounts, 3 VPCs. You're talking about 9 VPCs here itself. Now, why does this number of VPCs matter? Number of VPCs matter because as a cloud admin, you are responsible for securing them, which means you have to make sure that all the security groups in each VPC are consistent with your enterprise policy. Security groups do not straddle VPC boundaries, which means every time somebody creates a new VPC, you are on point to make sure that either you or the DevOps team is on point to make sure that that VPC security groups are consistent. That's actually a challenge. We call it VPC sprawl. That's clearly a challenge as this environment keeps growing. So we're going to demo to you today how we solve this problem. And while Amol's sort of coming up and showing you this demo, the intention here is to basically give you a view of all these clouds, all these accounts, all these VPCs in one solution. Give me a sec.
Okay.
You ready?
Yep. Okay. So this is my live environment that I'm running NSX Cloud here. What you can see here is the NSX Cloud dashboard, which provides me a few tiles on the top. The one that is of interest to us is the inventory tile. It provides me with the inventory in terms of how many VPCs I have configured in my environment, and then number of instances running. You can basically refresh it. It kind of pulls the inventory from the back end. What I would like to show is the Cloud Service Manager, and this is one of the components that we have created as part of this solution. When I click on the Cloud Service Manager, it will actually provide me with more details about how things are actually configured at the back end. So you can see that I have a couple of accounts configured here in the Amazon. I have a dev staging account, and then I have a production account, which is a different account in Amazon. And it provides me, in each card, I get a view, summarized view of how many VPCs are there configured in each account. And then these donors that you see here are actually pretty live. So what they do is they tell you how many of these VPCs are managed by NSX Cloud, and then the ones that are not managed are shown in gray. If you have a problem in a VPC, it will show you red. So right now we don't have any red here, but it will actually tell you how many of those are red. Similarly, it will also tell us how many instances are being managed within that entire account. So for example, we have 19 instances, and if I mouse over here, it says 8 managed instances, and the remaining 11 are unmanaged right now. And similarly, with the production account, we have 3 VPCs, 2 of them are managed, and 1 is unmanaged at this point, and the 13 instances are running here. So what I can do next is I'll click on the VPC number here, and it will tell me right away how many VPCs are configured in my particular account. So this gives you a nice organized view of VPCs and instances, and we'll go to the next screen where it will actually tell you how many instances are there in each VPC. If you look at today, if you go to EC2 Management Console, you have a VPC console and you have an EC2 console. No, the VPC console doesn't really give you how many VMs are running there. And when you look at the EC2 console, you can do filter on the VPC names and IDs, but then you need to know which ID to put in the filter and those kind of things. Let me click on the VPC, staging VPC here, and what you will see here is this VPC is NSX managed. What it means is, as a first step to manage the VPC, I have to deploy what we call as the public cloud gateway. This is the NSX public cloud gateway, which runs inside Amazon, inside your VPC. And then once the gateway deployment is done, then that VPC is considered to be managed. So at this point, you can see that I have my primary gateway, which is active, and my standby gateway, which is, or secondary gateway, which is standby here. If I click on the instance tab, you will see all my instances running. What I'll instead do is actually switch the view to the card view, and then you can see all the instances that are running inside my VPC. I have the gateways that are listed here again, but then I have a staging VPC where I have web staging books 01, 02. I have the DB instance as well as the app instance running here. It also provides me with the health status in terms of whether the NSX configured for this particular instance running in Amazon is healthy or not. If there are any errors, it will show me a down arrow with a red in there. And then we'll talk about quarantine in the subsequent demos, what quarantine means. So I'll just stop at that, but it will basically give you the real-time status of how the VM looks like in Amazon as from a NSX viewpoint. Next, what I'm going to do is click on the instances. Now this gives me all the instances that are running in this particular account in one particular pane of glass. I can quickly go and switch to a different production account, and now I see the instances running in the production VPC. So you can basically switch back and forth quickly to get a view of what is happening inside the other account without having to kind of re-log in or assume role in Amazon. The next thing, again, the filter works here. So if I want to basically drill down into, let me look at my production VPC, I can just filter it out. Then I see my production VPC VMs. And then similarly, if I go switch to the VPC2, I get the view of VPC2 at that point. So this way, you kind of get, what's happening in your thing. And as Percy mentioned, if you as a cloud admin cannot see what's running in your Amazon account, you can't protect them. So this is the first step of getting that visibility into those accounts. And once you have it, then you can start configuring policies. I'll just go back to the accounts tab. As you can see, I have added 2 accounts. I can always add multiple accounts for this particular NSX cloud. Over to you.
Thanks, Amol. So again, the key point here is to show you was a consolidated view, right? Green is good, red is bad. Anytime you see a red on that screen or a donut, you know that you need to double click on it. Whether it's in which account, which VPC, you can trace it down all the way. You'll actually get, okay, this particular VM, I set a certain security group, it's not applicable, somebody turned something off, I need to go double click on it. So this is the first piece of the visibility aspect, right? Again, the idea here is single inventory view across all VPCs. Now, it's not just VPCs, it is VPCs, regions, and clouds. So that is where it now becomes truly powerful, because I'm talking about multiple accounts over multiple clouds. This is clearly a future slide. We're talking about AWS and Azure in the single pane of glass, but the intention is exactly where we want to be, right? All your cloud accounts across multiple platforms consolidated into one view. So again, this is to point out that this is the Azure VNets, not VPCs that we're talking about. So let's click to the next one, right? We've talked about visibility. Okay, I get it. I can see what's happening in the cloud. The next point I talked about is the security piece. So again, goes back to the main point here, right? Whether you are in Azure or whether you are in Amazon, you define the security per VPC, which means every VPC you're managing, you need to have security groups. And as I mentioned, your average number of VPCs is like at least 20 plus. Some people go up to 400, which means now you have 400 touch points where you need to make sure are consistent with your security policy. If one of this is not right, then you have a hole in your security environment. Second piece here is, let's not do this. Let me not have 400 VPCs. Let me try and consolidate all of them. When you start consolidating VPCs, you hit cloud resource limitations. 50 groups, I guess 50 rules for inbound, 50 rules outbound. There are lots of these limitations that come in as you start increasing scale in your cloud environment. Last piece is also quite important, the static group membership piece. What does that actually mean? That means when the DevOps guy deploys the VM, he needs to make sure what security group it is in. Which means either, you, again, as I mentioned, you tell him, or you're sitting next to him at this deployment point, making sure that the right security group is sort of taken care of. Especially for production applications. How many of you guys have done that where you as a cloud admin and the DevOps guy are sitting together, make sure that it goes through staging, goes through production, and you are actually making sure security groups are consistent as the application is deployed. So the idea here again is have one single security policy. So if I can get one pane for visibility, I should be able to get one pane for security also. I define all my firewall rules in one place. Of course, that's NSX Cloud for us. That's where you have a single policy. Now, when I'm defining this policy, I can make it, I can use all the rich abstractions that are available to me. VM names, VM attributes, custom tags, user-defined tags. I can use all of these and define a security policy. Key point here is, this policy can be defined without the VM actually being deployed. That is where the dynamic membership becomes powerful. If I'm the security guy, I define the policies and I make sure that, look, Mr. DevOps, every time you deploy a VM, make sure that you follow this naming convention, make sure you put this specific user-defined tag. If you do that, the rules will automatically get invoked, the policy is automatically enforced, policy is always on. You don't need to worry about the security groups. As soon as the VM is deployed, that VM is secure because NSX is securing it. That is where the dynamic group membership becomes really, really powerful. You are decoupling the DevOps guy from the security guy. Let the security guy do his work, define the rule set. Let the DevOps guy deploy his VMs, make sure that he's developing it, deploying it. He just needs to follow the specific constructs that you define. Once he does that, he doesn't need to worry about AWS security groups or Azure security groups. And last is, because you're doing it in AWS, you don't have these cloud limitations. You can consolidate VPCs, you can expand them. You pretty much use all the powers that you have of NSX that is available on-prem, exactly like that in the public cloud itself. The other piece here is basically, great, I define the security rules. How do I know that these rules are actually getting invoked? How do I prove my compliance? How do I make sure that when an auditor comes on board, that my cloud is equally secure, just as much as on-prem? Now, on-prem, what I would have done is I would have taken my NSX deployment, I would have moved it to syslog, take all those log messages, show it to the auditor. He would have said, yes, you are compliant. I can see that you are enforcing security policies. Can I do the same thing in the public cloud? Today, you'll either use flow logs, in which cloud you're in, or you could just use NSX. Same rules, same syslog capabilities. It can be piped to any, the screen here is showing Log Insight. It can be any SIM tool of your choice. Basically, the way you're doing it on-prem applies directly to your public cloud itself. You get real-time operational visibility into your cloud security posture. In fact, when we do the demo, and we'll do that in a second, you can actually see that when we query those VMs, you'll actually see that in real time that these firewall rules are being invoked, and you can actually see that this is being logged in real time. The more important point here is operationally consistent with your on-prem environment. You don't have to manage a whole new way of proving auditors and auditability in the public cloud. You can just leverage what you have on-prem. With that, we'll go into this demo.
All right, this time I'm going to actually run a recorded demo here because it takes time to deploy VMs and stuff. So the scenario that we have here is really about
waiting for it to switch.
Switch, okay. Yeah. The scenario here is that we have a staging account where we saw that earlier in our live environment, where my application is staged, been tested, and it's mimicking the exact production environment, including my networking and security policies that are defined there, so that everything is well tested. And then when we'll basically, as we go through the demo, we will reach the go live date where we basically go and deploy the same application in a production account, in a production VPC, and we'll see that those VMs are protected right on day 0 when they get deployed. So that's how the scenario is laid out. So right now I'm wearing a cloud administrator's hat, and I'm looking at my environment. So we will review the environment and how it looks like at this point, and then we'll go through the deployment process. So if you look at here, I have some VMs deployed, 28 instances and 7 VPCs that are created. What I'm going to do is I'm going to go into the Cloud Service Manager and click on this cross-cloud as we saw earlier. We have these 2 different accounts out here, the dev staging account and the production account we saw earlier in the live environment. When I go into my staging account, I can see my staging VPC, which is where my application has been staged. It has been managed, just like it will be managed in the production environment. When I click on this tile, you can see that the applications are there. We have the web staging 0102, the app 01 and DB01 VMs running in there. And then there are a few other VMs like Log Insight and staging Jumpbox VM running inside that particular environment. And finally, we have the gateways which are listed here, the NSX GW VPC here, which is the primary gateway, and then secondary gateway here. So let's go back to the accounts. Let's review the production account at this point. And since we are going to use the production VPC1 for deployment, we will verify that the production VPC1 is managed by NSX. As you can see here, we have the gateway deployed. But if you look at the instances, there are no application instances running, just a Jumpbox and the gateway, right? So let me go back. And now let's review the NSX policies that are running and protecting these staging VMs at this point. So when I go to the NSX tab here, I can click on the firewall policy tab, and you can see that there are a couple of sections defined in the firewall table. Let me just make it bigger. So we have the infrastructure rules. So now these rules are basically company-wide rules. As a security admin, I want to make sure that I block access or applications such as Telnet and FTP. I want to allow DHCP, DNS, those kind of protocols. Syslog should be allowed only to my syslog servers that I have configured. And then finally, SSH and RDP should be allowed only from my management host to those VMs. So these rules will be applied across all VPCs because I want to basically keep it broader. So any VM gets deployed, they always follow these rules. So, okay. Let me just close this table here and expand the 3-tier app table. Now I have defined a 3-tier app section, rule section here, which kind of covers my application VM. So I'm defining policies very specific to that application. First thing I did was created some security groups. These are dynamic security groups from NSX. Those are the web tier, app tier, and the database DB tier groups. The condition that I have used is VM name contains web, will fall into the web tier. Similarly, app and DB is defined, right? But when I created the policy, the groups were empty because there were no VMs even before the staging environment was built, right? Once we deployed the staging, they got populated, and we'll look at these rules here. So you can clearly see that I have the any to web tier allow port 80. Similarly, between web tier to app tier, I have HTTP, right? So let me just click on the web tier to see the membership. You can clearly see that there is a web STG01, and then you have the web STG02, part of this particular group. Similarly, let's look at the app tier, which we have the app VM that we saw in the staging VPC, and then the database tier, which is also part of the database group. And then finally, I have defined any drop, so that I make sure that anything apart from these rules should always drop the traffic. So let's go back to my dashboard. Now what I'm going to do is wear the developer's hat. So I'm now no longer the cloud admin, I'm the developer now. Today is the day when the application goes live. I'm a DevOps guy. I've created this CloudFormation template, which I'm going to deploy in Amazon. So if you guys are familiar with CloudFormation, this is how it looks like. You go and create a stack, right? And then you provide a YAML or a JSON file that you can upload into the CloudFormation. And once you do that and click next, you have to go give some name to it. So I'm calling it production app 1. And I'm deploying in my production 1 VPC. If I click next, I leave all the options as default, nothing to select here. And once I do, let me just, okay, yeah, this is better, I think. Once I click on create, what it's going to do is basically start creating my VMs. As you can see here in the log messages, it creates an elastic load balancer, adds the web VM at the back end, it creates some Route 53 entries, all that stuff. And once everything is done, you will see that the create complete is shown here. And then in the output, I get the output for the ELB, which is how I can access my 3-tier application. If I just copy paste this into the next tab, I can see my application is working. It's a 3-tier app. And then if I click refresh, I can see it's load balancing between my web and app VMs. So now that the production application is deployed, what I'm going to do is go back and revisit the Cloud Service Manager and then look at the production account here. And what you will see there is the production account now shows me 5 VMs. So you can see that I have the Jumpbox VM, which was already there. Apart from that, we have the web VM, the app VM, the web 02 and 01 here, and then we have the database VM also running inside the VPC. And you can see the status is NSX state protected, which is green at this point. What I'm going to do next is basically, how do I really believe this is protected? So what I did was actually did a scan, Nmap scan on this particular VMs on the VPC subnet. So I just ran an Nmap scan from my Jumpbox. And when I do that, you will see that my web VM and 1 and 2 will respond to port 80, which is the HTTP protocol, it says. And you can match the IP addresses 5.105 and 5.182 that are all listed out here. And the rest of the VMs did not respond to the Nmap scan because they were protected by NSX, and they are not supposed to talk to anything but the web at that point. Right? So that kind of gives you that, oh, these VMs are protected. Now let me show you how the policy will look like from a dynamic group membership perspective. So we'll quickly go into the firewall rule table here, close this section, go into the 3-tier app. And we can see that you have the web tier, and this time when we click on it, you will see, and we'll scroll down and we'll see that my production VMs are now listed automatically. So basically, based on the condition that we provided for the dynamic group membership, once the VM got instantiated and it matched the condition, they all got added into the right security groups, and then the security group basically applied the policy. So the next section is basically I'm going to play this video where it will show me the login site tool. So what we have done is we have configured syslog server on the gateway, the NSX gateway component, which forwards the log to my log collector. It could be any syslog collector. In our case, we use login site. And you can basically see nice charts in terms of what was the traffic allowed, like top firewall sources, top firewall destinations. You want to see what was permitted through the firewall and what was denied by the firewall at that given point of time. And we'll just go through this further. And we'll actually click on one of these widgets. So if you guys have used login site, it's probably familiar for you guys how login site looks like. So we'll basically click on it, and let me just forward this video, which is embedded here. Okay. So what we'll see here is the log messages which will correspond to my traffic that's hitting my MySQL server, and the S indicates the SYN flag on that particular log message. Similarly, we'll look at the log messages for the deny flow, because when I did the recording, I actually did an nmap scan on my environment first and immediately did a capture. So you'll have all these nice fancy wheel which shows me a lot of denies. And you can see that my Jumpbox VM was trying to kind of port scan on multiple VMs on 443 in this point of time, but it will basically give me the real-time log message. So that concludes the demo.
Thanks, Amol.
Sure.
So, guys, again, the point to sort of show you here was the fact that, look, you don't have to go at the time of deployment and recreate security groups, security rules in every VPC that you're deploying VMs in. You've done it once through NSX, and that applies everywhere else. Now, take the same demo, and let's say tomorrow we support Azure, and we basically deploy it in Azure. If the security constructs remain the same, the attributes remain the same, it will automatically apply to that Azure, or just to a new VPC in a different region, etc. The idea here is you're deploying your policy once, and every time you deploy your applications, the policy is following the application. Wherever you deploy it, you don't have to go and write new rules at that point. So that's what we sort of talked about in a runtime application, right? Now let's talk about something else, which is the default quarantine. What is default quarantine? Today, when you go to AWS, we are basically saying use NSX as your first layer of defense. That is your place where you define your security rules. What if one developer, whether maliciously or accidentally, decides not to apply the right tag, or decides to basically say, you know what, I'm going to call my VM in a completely different name? Then those security rules don't apply. So now do you have a hole in your security policy? Well, it turns out, depending on what you want to do. So let's say you have a test and dev VPC. VMs are coming up, being deployed, and then they're torn down because the developer is really quickly trying to get his application up and going. In that environment, you can have some VMs that are managed, which is by NSX, and then there are some VMs that are unmanaged. NSX is not deployed, it's not configured, and you can sort of have that it's a test and dev VPC. I'm securing the VPC from a different standpoint. I'm good with that. But if you're in a production VPC and you want to make sure that every VM there is managed by NSX and is applicable to those firewall rules that you defined, you can turn on default quarantine. What that means is anytime a new VM is deployed in that VPC that does not adhere to the security policy that you defined, whether the guy didn't have the NSX component on it, whether he put the wrong tag, whether he just had a typo in the VM name, if you have a VM that does not get well, that's, I'm not sure where that came from, but if you have a VM that does not have the NSX configured correctly, you can quarantine it. What that means, we program the AWS security groups behind the scenes to make sure that every VM is either managed by NSX, that's your first layer of defense, or by NSX managed security groups, that is your second layer of defense. So if you're a DevOps guy and you want agility in a test and dev environment, have at it. But if you're deploying in production and you want to make sure that every VM is taken care of and is accounted for, you have more structural integrity through default quarantine. This is as simple as turning on and off default quarantine in the NSX console. So when, in the CSM, when you're deploying the gateway, you specify that this is a production VPC. I want to turn on the ability to quarantine. From that point onwards, the VM is either managed and is allowed to run with the NSX parameters, or is unmanaged and quarantined, which means it has no connectivity to any other VM in the VPC or to the outside world. We'll actually show that to you also in a demo. So this is our third sort of security demo where we are actually showing VMs that are coming up, but because of quarantine being on, they will automatically be quarantined and there will be no connectivity to that VM.
Okay, let me switch to the quarantine demo here. So basically what I'm going to do here is we deployed the app in production, everything was running good. Now some developer, probably ignorant or doesn't understand the rules, just goes and deploys a VM which doesn't get managed by NSX, or they're just trying to circumvent the security. So just to simulate that deployment, what I'm going to go through the EC2 console here and just launch an AMI here. So I have this rogue VM AMI. I'm just calling it out as rogue VM. No one will do that, but anyways. You launch the instance, so go through this stuff. I'm sure you guys have done this in your own environments. And then we define where we want to deploy. We selected the production VPC. We go here, click on the name, and then put a tag called rogue1, just so that we can identify it in the CSM, that particular VM, and then go configure. And this is important, actually. What I'm going to do is I'm going to use this allow all, free ride kind of a policy, which is like allow all traffic for my VM. Obviously, it will not be managed. And I'll give it a go, give it a shot and see if I can basically just bypass the security. This is part of the PEM file, to launch the instance. I'm launching it out. And then once the instance is launching, we'll go and look at the status. So what happens is, since this VM doesn't get managed by NSX, what we do is we actually go underneath, on the VPC side and change the security group of that VM to a default security group. Now what we are doing really is we are using this default security group for the VPC for special purpose, for enforcing quarantine. So we configure the rules on that, and we restrict the access down to a very limited access, so that you can only talk to the gateway to get managed. That's all you get and nothing else, right? So we can actually look at the inbound rules on who can talk to this particular VM. This is typically the gateway can talk back to the VM to get it managed. So that's how we kind of enforce quarantine policy by switching them from an allow all security group to a default security group, which is used for quarantine enforcement. Now let's go and see how things look inside my dashboard. So as soon as we did the quarantine, that thing kicked in, we can see that in my dashboard itself, I can see a red here, I can click here, and I can see there's one error. But to know more details about this, I'll go into my Cloud Service Manager. You can clearly see that the production account is showing me a red here. I'm going to go drill deeper into the VPC. And you can see there that my rogue VM actually got quarantined, and it's showing it nicely in an icon saying this VM is now, although sudo managed by NSX, because we are managing the security group underneath for that particular VM, we are basically saying this VM is quarantined. I can always click on it and get more details about the VM, what's the IP address and those kind of things if I need to. But the state indicates that it's been quarantined. So this way we are basically having this defense in depth, dual layer security. Primary layer is NSX firewall, and for any reason the VM becomes unmanaged, we go and quarantine the VM at that point in a VPC which is quarantine on. Right? Okay.
Thanks, Amar. Sure. Guys, of course, we have sped up the demos because we are showing a lot to you. So, of course, you see these videos that are all sped up. You know AWS VM deploys in seconds. But that's the idea. We wanted to actually show you all these capabilities here. So, especially things like default quarantine, that is net new. That is net new even from a security standpoint. This will apply to every cloud that we support. So, instead of basically saying my cloud security is specific to the cloud environment I'm running on, you have NSX as your overlay cloud security layer, and then all of these other features and capabilities come with the NSX cloud. So let's switch from the security piece and come back to the networking piece. Now, initially, I talked about bring your own network, right? You can define a logical topology. Typically, what you do today, in the on-prem world, when you're using NSX, you're creating logical topologies for isolation, etc. And then when your application is deployed, it basically, you don't worry about the physical underlay that you're deploying on. You worry about what logical switches and routers I'm using within NSX on-prem to manage my application. Take the same paradigm and extend it to the cloud. So now you have one single network policy that straddles your hybrid environment. You have full control of IP addresses. This is an overlay network. You are not limited to, what is the IP addressing scheme of this VPC? Should I peer the VPCs? Now my CIDR ranges are overlapping. How do I manage all of this? It doesn't matter. This is a logical network. You're defining it. You can even stamp the same network out multiple times in different VPCs. It'll work just fine. This is entirely defined in NSX. You can have the same IP address in AWS and Azure, in whichever cloud that you're managing. So the intention here is you're using this overlay network to basically deploy an application agnostic to what your physical footprint is, whether it's on-prem or whether it's AWS. The other interesting thing here is when you're going and deploying applications in AWS, one recommended best practice is, make sure you stretch your application across availability zones for resiliency. If this one zone goes down, you need to sort of be in a different zone, etc. Now that means you have to now create subnets, etc., and make sure that your application deployment stitches these environments together for resiliency. Here, I can have a logical network and then stretch that logical network topology across an availability zone. So even though my application is deployed on the single network, but because I'm deploying it across availability zones, I get that resiliency, but I don't have to factor in these two different networks in my application deployment. If you're an application developer, you focus on the application, I will get the resiliency across availability zones because you're developing on an overlay network. The second piece here that I want to talk about is TraceFlow. So this is a tool within NSX. And one thing that TraceFlow can be used in public cloud is basically to give you visibility into east-west traffic. So let's assume everything goes fine, you're deploying those applications. In VPCs, do you have any visibility into how these VMs are talking to each other from an east-west traffic flow standpoint? You have to either look at logs and flow analysis to figure that out, or you could use TraceFlow. We'll actually demo this TraceFlow to you also here, which gives you how you are traversing from one VM to the other VM within the VPC using NSX TraceFlow. So just roll to the next slide.
All right, so basically this will be the last demo for the session. What we will do is essentially show you, so we did not do a demo for how to configure a logical switch because that would be a much lengthier demo in terms of creating logical switches, connecting to the routers and stuff. Instead, what we wanted to show you is the TraceFlow output, and we will walk through how things are connected on the overlay at that point. So here, this is the screen again, back to the NSX Manager. When you click on the tools and the TraceFlow, let me just make it a little bit bigger so it's better for you to see. So you can see that there are, it asks me to specify what type of traffic I need to inject. How many of you guys have used TraceFlow in the past? A few of them, okay. So basically, the TraceFlow is a tool in NSX which lets you inject an artificial packet in the subsystem, NSX subsystem, and then the packet basically follows the routing and switching rules as it would take, actual packet will take. But while doing so, it will provide you some observations back to the management system saying, this is the path that the packet took from point A to point B. If it gets dropped, we know where it got dropped. If it doesn't get dropped, it reaches on the other side, we know how it went through, what firewall rules allowed to get through all that stuff, right? So that's the purpose of TraceFlow. So what I'm going to do here is, I'm going to run a TraceFlow between my web VM, which is the web production VM I have deployed in my production environment. And then as I select that, I can see that my instance ID is listed here. And then I can see my overlay IP address that has been configured in the subsystem here. I'll go and then select my second VM, which is my application VM, the app prod SV01A, and I get the similar IP address. It's 10.10.20.51. So you have a 10.10.10.0 and a 10.10.20.0, two different subnets, and that are connected by a router. And we will see how they are connected as we see follow the TraceFlow output. I'll also make the TraceFlow type as ICMP. So let me just make it smaller again. So I can select the traffic type here. It supports ICMP, TCP, and UDP. I'm going to select TCP because I want to basically test some stateful firewall policies that I have configured between my web and web and app. And I'm selecting the source port as some high number, and the destination port is 80 or HTTP. The SYN flag is set. So that it checks and makes sure that it passes through the firewall. And once we click on the trace, it will basically inject the packet. The packet will take its route, and at some point, the observations will come back to the manager, and then we'll see a nice output here, as you can see here. So I can see that my web VM running here is attached to my web logical switch. And it gives me the details about that web logical switch. I have a tier 0 router, which is my logical router in NSX, which is connected to the web logical switch. And on the other side, I have the app logical switch, which is also connected there. And finally, you can see that there is a VM that is actually connected to my web logical switch. So it kind of gives you the lay of the land, how things are wired in the overlay space. At the same time, I can actually move on the right, and I can start looking at the hop counts. Just like you do trace route, here it's more detailed output. So I can see my, let me just close this. I have my web VM, which is connected to the VNI 3771, right? Let me just make it smaller. Then I can go look at the web logical switch. So the traffic entered the web logical switch. It went to my tier 0 router, exited the router. It actually came to my app logical switch, how the traffic came in. Then this is where actually the traffic went between my web and app VMs. Now the important point to note here is, even though we have deployed the gateway, my traffic between web and app is not going through the gateway. The gateway is not in the data path. It's directly connecting between the two VMs inside my public cloud network. So we can see that the traffic went from my web VM to my app VM, and then finally it tells me which firewall rule policies allowed, like 10.1035 was the rule ID that allowed the traffic until it reached my actual VM, and then it was discarded. So since it's a simulated traffic, what we do is we don't send it to the application stack, we just discard it silently. So this is how you kind of get visibility into how things are wired in public cloud on the overlay network, and how the traffic flows from point A to point B. That's the outcome. Sure.
Great. So we've talked about this whole trace flow aspect as well. So this was the demo that we did. Now, we showed you everything about NSX. So how is this NSX cloud? Is this NSX? What is it? The difference here is NSX, we give you the bits. You install it, it's your servers, your network, you upgrade it, you patch it, you have a perpetual license. Typically that's the case. NSX cloud, just log in and use. It's there for you in the cloud. You log in, you have access to it. You don't need to install it. You don't need to upgrade it. It runs in the cloud. We upgrade it, we take care of patches, you pay per use, and it's essentially available for you. That's the big difference between NSX and NSX Cloud. Notice that in this thing, we are not differentiating functionality. So all the functionality and most of the functionality that you have on-prem, absolutely available in the public cloud itself. Now, all of you guys, if you know NSX, okay, so then the next question is, if you're offering a SaaS, if you're offering a service, are you sharing my data with some other customer? No. You have a dashboard in which you access your own independent NSX deployment. Each customer gets their own NSX stack. So every customer has their own NSX manager, the cloud service manager. You saw 6 demos on the manager and the CSM. They have their gateways. There is no sharing between these guys. They're isolated environments. They only come up at the dashboard in which you access it. So all NSX Cloud customers log into the dashboard. They have their own NSX manager and CSM links. And from that, it's a dedicated deployment for your specific deployment, right? So it is completely independent from one customer to the other. In spite of that, basically, if you look at even deeper under the hood, it's the same NSX environment. You have your three-layered sort of NSX approach. You have your dashboard at the top, the management plane, the control plane, the cloud gateway, and this is where it gets interesting. Since we are offering the service, this is a VMware operated service, the dashboard, the management plane, the control plane is deployed in the VMware account. That's where you just come in, it's hosted for you, you log in, you start using it. What you have to do, and we'll go through that in detail in the next session, is you deploy the cloud gateways in each of the VPCs that you want to manage. So every VPC that you want NSX managed, you have a cloud gateway, a logical cloud gateway. You can have a pair for resiliency, so you have HA, but every VPC that you manage will have the cloud gateway. That's in your account. And of course, your data plane consists of basically the NSX component in the VMs. That is, of course, in your account as well. Now, the main thing which we will talk about is most people look at it and say, oh, but wait, so is this at the hypervisor layer? So in the public cloud, you as a customer do not have access to the hypervisor, which essentially means that any data plane component we put has to be in the VM itself. Now, this is typically true for any of the services. There are 2 ways you can actually provide services in the cloud. You either go down an appliance model, where all traffic is sort of consolidated to that one appliance, which means you add hops, or you go down this model, where basically you can give a truly distributed security environment with its own components specific to that VM itself. And we'll cover this a lot in detail in our second session. I wanted to at least give you basically what that stack looks like. So, if this is a cloud, and I mentioned you don't have to upgrade, you don't have to manage, what do you have to do? We deploy, we upgrade, we patch, we maintain. You write the firewall rules, you write your network policies, and you basically look at operational status. So essentially, you are responsible for your own environment, your security policies, your network policies, bringing VPCs on board. That's all your responsibility. Everything else regarding the uptime of NSX is our responsibility. It's as simple as that. So hopefully this is exciting enough to you guys getting started. So again, no deployments required, no installation required. Just go to this website, cloud.vmware.com. We explain all the services there. NSX Cloud is explained. Click there, request access. There's a small form to fill up. We are in initial availability today, starting today. So as I mentioned, go click there, put in your details. It'll go through an approval process. If you're approved, you can start using it today itself. Again, the idea here is it's free for the initial availability period. It's already deployed there for you. All you have to do is request access. Once you get access, you just start using it. Create your rules, onboard your VPCs, and have at it. One last slide. Lots of sessions at VMworld. One particular session to emphasize is the second continuation of this service. What we explained to you today is what NSX Cloud is, how is it built, what are the components, how do they all function together. That's tomorrow, same time in MMC2046BU, which is the session tomorrow, which is part 2 of this session, where we'll go deep into the weeds of NSX Cloud, and you can actually understand exactly how this entire service is being brought up for you. With that, I think this is our last slide. Definitely please fill out the survey. Any questions, concerns we can help answer. I know we are pretty much the last session of the day. Yes, sir. So if you can just come to the mic, or I'll repeat your question.
So one thing that we didn't cover, I was curious about, is we can use NSX Cloud to manage our cross architecture with AWS through Cloud Gateway. I got that part. But if we don't have on-prem NSX, can we use the NSX Cloud to manage the prem?
Great. Let me repeat the question. If I don't have on-prem NSX, can I use NSX Cloud to manage my on-prem? The answer for now is no, because the NSX Cloud is a service we launched today, and it's available for AWS environments. But I will mention one thing. You don't need NSX on-prem to manage NSX Cloud for AWS. So if you have an AWS environment, you don't have an NSX on-prem, you can still use NSX Cloud and just run it there. Yes, sir. Yes. Right. The question is, if I do have NSX on-prem, can I import my security names, tags, groups, etc. in NSX Cloud? Short answer is we are working on it. We want to give you consistency across your environment. So of course today we announced the service. It's only for AWS today. Expectation of course is it's going to straddle Azure and then hybrid as well, which means your single frame of glass across on-prem, AWS, Azure, and other clouds we support. So it's in the works. Yes, sir. It's fully, is there an API is the question. It is fully API driven. The UI that you saw is built on top of the API, so you can completely use the API for whatever work you need to do. I'll ask him and then I'll come back to you. Yes, sir.
Why doesn't the cloud version have the same looking feel as
the question is, why does the cloud environment does not have the same look and feel as the NSX manager? I guess the short answer to that is we wanted to make it really, really simple, and especially for the visibility piece, etc., that we deployed with CSM. We have a slightly different architecture in which we deploy it in the cloud versus on-prem. You see look and feel differences. Policy-wise, intent-wise, feature-wise, you will get lots of feature parity as we go forward. I'll come back to you. Yes. Right.
You're getting over some of the security limitations on those individual clouds, the number of security groups, things like that. But we study this fragmented environment where you have a cloud product and an on-prem product. Is the API between both of those something really common? Because I know there's NSXB, there's NSXT.
Yes.
All of those are different APIs.
Right.
The question is, how are we putting that
That's a very good question. I'll just repeat it. So there's NSXV, there is NSXT. How are we bringing all these together? How are these APIs going to be consistent? So NSXV, when it came out, was defined, and specifically it's NSXV for vSphere. NSXT, as is being deployed and created, is basically agnostic to so you can run it for managing your on-prem vSphere environment. You can run it to manage containers. There is a session to manage containers. You can run it to manage public cloud. The intention here is that is your API that is, of course, consistent. Now the question is, if I have a V deployment and I have NSX Cloud, how do I bring these all together, right? So we are working on an abstraction layer or a policy layer that straddles both of these environments. So you have policy consistency between both worlds, but that's again an evolution that we are sort of going forward. Any other questions we can help answer? All right, I know we've sort of spent a little bit over time. It's 6 o'clock, so hopefully you have a great evening. Thank you guys for attending this session.